Hello world, it's Calcutron here with another TI Basic tutorial. In this episode and the next one, we're going to be learning about just a few of the mathematical operations available on the calculator. Many, but not all of the useful math functions can be found by hitting the math key, which is right below alpha. Hopefully you remember that hitting second and then math was what we used to get to our relational and logical operators. So second math got to test and logic, which again are the relational and logic operators. If we don't hit the second, then we get one of the largest menu systems on the calculator, maybe the largest. It has 4 tabs and 41 menu items. But don't let it overwhelm you. We will only be working in the number tab today, so that's the second tab on the left. These functions do various things with numbers and are useful not only for math, but for programming. So let's start out at the top and work our way down. So the first command is abs, which is short for absolute value. You can see why they shortened it. And it's a fairly simple command. Hopefully you've been exposed to this idea before, but you pass it in a single number argument, or at least that's how we're going to be using it now. There are other ways to use it, but you pass in a single number argument and it looks like it just gives you the same thing, but when you pass it a negative number, such as negative 30, then you get out a positive number, and you'll notice two things. First, I am not using parentheses on the end, and I believe we've discussed this before, and we will discuss this in more detail again, but in general, ending parentheses are not necessary a large amount of the time. Only when your expression is nested within another one and you need to end it, do you then put an end parenthesis. And so we'll talk a little bit about that more later, but in general, if you ever have end parentheses on the end of a line, like say there's a bunch of complicated stuff in here, and you're ending a whole bunch of function calls, you can generally omit all of these end parentheses, but we're going to talk more about that later. So just don't be confused by that today, because we're going to be leaving off our end parentheses. The second thing to notice is that if you're following along at home, this might look different from what you see. It is likely that instead of this ABS token, you got 2 vertical bars, which is the more traditional notation for an absolute value. If you get 2 vertical bars, then it means that you are in math print mode. To see which mode you're in, you hit the mode button, which brings up a whole bunch of useful settings. Now if you scroll to the second page of this, then the first item on the second page allows you to select between classic and math print mode. Now this is what affects how the absolute value operator looks. So if we switch to math print mode, which is actually the default, and I'm guessing it's what most of you are using, and then we retype our absolute value, we get the vertical bars that I was describing. Now pretty much everyone I know uses math print mode, but today I'm going to make the argument for classic mode. So the first thing that I dislike about classic mode is that when you're typing a long expression, so let's type something big. So big numbers adding together. We're doing some very serious science here with these big numbers. What happens is when you get to the end of the line, it just increases the length of the line and scrolls you to the right. Or it gives you more space on the same line, and it hides the beginning of the line. And now personally, I am not a fan of this, because I can no longer see the beginning of the expression I was writing. And if I was putting on parentheses at the end of something, and I did need those parentheses, which sometimes you do need on parentheses, and I forgot what was at the beginning and I don't have a perfect memory, I might have to scroll all the way back to see, oh, I had 5 function calls that I needed to end parentheses for. And if we switch back to classic mode, you'll see that classic mode actually wraps the screen. So if we're typing in long numbers, it will wrap the screen onto multiple lines. Now the second thing that rubs me the wrong way, or that I don't care for too much about math print mode, is if you're doing a long expression and you're using radicals and some exponents or other things, what it will end up doing is taking up more vertical space. So if I go ahead and invert this expression a couple times, maybe that many, it's taken up almost half the screen in vertical space, and once again, because it wraps, or because it doesn't wrap, we can't see the beginning of our expression anymore. And this just takes up a lot of space. And I much prefer classic mode. And in classic mode, everything will go in one place, all on one line. So before, that would have taken up multiple screens worth of space in math print mode, and on classic mode it all fits on one line, and we get an answer of 5. Now the other thing that, or one of the other things I don't like about math print mode is you have to move your cursor more often. So if, once again, we're typing something with an exponent, now we're up in the exponent, and let's say we want to raise it to the 6th. Now if we want to keep typing and we want to do 5 to the 6th plus 6 to the 6th, two separate things being raised to exponents added together, we can't just type plus 6 to the 6th, because it'll put it in our exponent. What we have to do is move our mouse around a bunch. Oh, and now this thing's here. We gotta delete that. Oh, see, I'm all lost already. Things aren't going well. Now, it's a lot of pain, a lot of effort, but I finally typed it the correct way. So when you're using math print mode, you often have to move your mouse around to get, or not your mouse, but your cursor with the arrow keys to get around your expressions, whereas in classic mode, if you're doing things efficiently and you know what you're typing ahead of time, you never have to touch the arrow keys. I saved the most important reasons for last, and the last 3 have kind of been personal gripes I have with math print mode, but one thing that you should care about that math print mode does is it actually slows down your programs. So it's not super significant, but it is noticeable. So it's not 2 times slower or even close to 2 times slower, but math print mode programs do run slower, and especially if you have like a game or something where you need responsive user input and you're doing a lot of outputs to the screen or some heavy calculations, math print mode does slow down your program noticeably, and classic mode inversely is much faster than math print mode, so that's something you should care about. But the main reason why we're not going to use math print mode in this series, you hopefully will never see me using math print mode, is because we cannot type expressions with the nice math print mode syntax when we're in the program editor. So this nice absolute value sign here, we can type it fine on the home screen. As soon as we go into a program, when we try to type our absolute value, it shows up in the classic mode way. And we have to put our end parentheses in and all that jazz. So that's the real reason why you shouldn't use math print mode, and it's because you can't program with it. And all the time when you're learning new things about this calculator, and unless you know everything, which not many people do, hopefully you're always learning new things about how to use your calculator. And whenever you learn something, you should be thinking about, how can I use that in a program? And it helps if the syntax within your program editor is the same as the syntax you're using outside. So along with my personal reasons and the long history I have using classic mode, it's just something I'm more used to, and it's something you can get used to too. Alongside that, it's also just practical. You will have to learn classic mode in order to program, and I would say simplify it by only ever using classic mode. But that's a decision you should make for yourself and your own calculator needs. I'm just going to let you know what math print and classic mode are, what does it change, and it's more than just the absolute value function, and I'll let you make that decision for yourself. So back to mathematical operations, we have our absolute value, which takes negative numbers and makes them positive. That's how it works on real numbers. Next up is the round function. So you may have guessed that this will round numbers for you. So let's put in a decimal number, so like 6.12, and we'll get 6.12 out. So let's try this with a number with more decimals. Let's try it with something like pi. So if you didn't know, your calculator has a pi button on it. So never again do you need to memorize dozens of digits of pi. You can hit second and then the caret key, or oops, did I hit 2? I meant to hit second. Second and then the caret key, which is also the exponent key, or it corresponds to alpha h. So that gives you pi, and if we round pi, well, it doesn't look like it actually changed pi either, but what's really happening is by default, when you don't tell it how many decimal points to round to, it's rounding out to, I believe, 9 decimal points. So normally if we do pi minus pi, we get 0. And if we just look at pi, it's actually displaying the same thing that a rounded version of pi is displaying. And that's because while you have, I believe, 14 digits of accuracy on your numbers, you are only able to display, I believe, 12 digits at a time. I may be wrong about that. That's off the top of my head how many digits you can display. But if you do pi minus the rounded version of pi, you'll see that there's actually a difference. So the rounded version of pi is actually 4.102 times 10 to the negative 10 smaller than actual pi. So it's rounding off 4.102 times 10 to the negative 10 from pi. Now this is interesting, but the round is much more useful if you give it a second parameter. So this is another one of those functions with optional second and third. Well, this one doesn't have third, but other functions do have optional third parameters. Just like 4, it had an optional fourth parameter. So this has an optional second parameter, which is the number of digits you want to round to. So if you want to round to 2 places after the decimal, that will give you 3.14. If you want to round to 3, you'll get 3.142. So if you're thinking it would be 3.141, you have been tricked. And what round is doing is, and hopefully this isn't your first time being exposed to it, it's taking the digit you want to round to, and it's looking at the digit after that, and if it's 5 or greater, then you round up. If it's less than 5, then you round down. So if you rounded to 2 digits, that was rounding 3.2, 3.14, because the 1 that follows the 4 is less than 5, so it rounded down to 3.14. When you round to 3 digits, it's rounding up because there's a 5 following the 1. And important to note, it doesn't matter the digit before or the digit that you're rounding to. So if we were doing this, we could do 3.1415. It doesn't matter that there's a 9 after the 5, it only looks at the 5. And it doesn't matter that this is a 1 before the 5, it only checks the 5 and it will round up whether or not this is even or odd. The next function we're going to learn about is ipart, and that stands for the integer part of your number. So integers are the values with no decimal. So the I part of pi, let's see, the I part of pi is 3, the I part of 5.64 is 5, the I part of 54 is 54, and the I part of negative 54 is also negative 54. So this just takes the integer part of the number. So if it's negative 54, it's going to be negative, or if we put a decimal, it's not going to care what that decimal is, or if it's greater than or less than 5. It doesn't care. It will just take the decimal. So this is what's called truncation. So just the integer part. The next function is fpart, which stands for the fractional part. So if we were to do that again, negative 54.25, close enough, it's going to give us negative 0.26, so that's the fractional part of that, and positive numbers, it gives us just 0.26. Now the next command is int, and It looks a lot like, and it works a lot like IPart. So if we do 5.6, it's going to give us the int, and it, once again, is always going to truncate. But for negative numbers, so what int is actually doing is it's rounding down to the nearest integer, whereas what IPart is doing is it's just taking the integer part of that number. So if we do our negative 5.4, what int is going to do is it's going to round down to negative 6, whereas what IPart was doing was it's just taking the integer part, which is negative 5. So that's IPart and int. And now this doesn't usually matter too much, but int is actually a little faster for smaller or shorter numbers, whereas IPart is a little faster for larger numbers than int. But so that's why we're probably going to be using int more often than IPart. But essentially they have the same behavior, except for when you get to negative numbers. Now, finally we're on to command 6. Command is min, and this takes 2 parameters, so not 1. And if those 2 parameters are integer, it just tells you which one is smaller. So 5 and 6. And 5 and negative 6, negative 6 is smaller, even though it has a greater absolute value. And doesn't take a third integer parameter. So it only works on 2 integers, and it will tell you which one is smaller. And it works on decimal points as well. All that jazz. Max, exact same thing, except it tells you which one is larger. So 5 is larger than negative 5. It's also larger than negative 10. We see what's larger, 5 or 5. It was 5. Crazy math going on here. Now our next command is LCM, which stands for least common multiple. So the smallest common multiple between 2 and 3 is 6. Least common multiple between 2 and 8 is 8. So if both numbers are prime, it'll be the first number times the second number. If they're not, it'll be the least common multiple of the 2 numbers. So that is that. Next command is GCD, which is greatest common denominator. Again, hopefully these words and commands are maybe at least a little familiar to you from math class, if not very familiar. So like 10 and 20, what is the greatest common denominator? It's 10. So both of these numbers are divisible by 10, and that is the greatest thing that they're both divisible by. And if we do like 5 and, well, let's do something bigger, 50 and 75, the greatest thing that both of them are divisible by evenly is 25. So that is least common multiple and greatest common divisor. The next one is one of the more useful ones that a lot of people sometimes forget about, and that is remainder. Quick note, if you're following along and you don't see remainder, some operating systems won't have this, and there will be many commands that you may be missing. But don't worry, we'll show you how to simulate remainder using other commands we've learned already. So remainder just tells you if you give it 2 integer arguments, it will divide them, tell you what is the remainder. So 5 divided by 2 has a remainder of 1. So 2 goes into 5 2 times with 1 left over. And this can be quite useful. So quick note, if both numbers are divisible, or if the first number is evenly divisible by the second number, the remainder is 0. And this is the easiest way, or one way, to check if a number is even or odd. So even numbers will be a 0, odd numbers will be a 1. That's something you will sometimes come across when you're programming. If you don't have the remainder command, we can fix this by doing the fractional part of a division. So the fractional part of 5 divided by 2 gives us 0.5, and then we just multiply that by the the denominator, the thing we're dividing by, and that will give us a remainder of 1, and if we were to do an even number, we can get a remainder of 0. So that's a nice short way if you don't have the remainder in order to get the remainder of a division. Now, our next command. This was actually the last useful command, and I won't go so far as to say that you'll never use these. We actually have already used command D in this episode. It was what we used to get a fraction bar, but these four are so unuseful when you're programming that I am not going to cover them. They deal with converting between fractions and decimals. That's all I'll say. So that has been our episode on number operations, episode 9 in our TI Basic tutorial series. If you have any questions or comments, please leave them below. I know this was kind of a long video, but I still hope you enjoyed, and the next episode I assure you will be less than 20 minutes. So stay tuned for that. Otherwise, I hope you enjoyed. Bye-bye.